I'm Annie Majewski, and today I'm presenting about a 3D printing class I'm taking here at CSU. It's for engineers, and my major is mechanical engineering. The reason I wanted to take this class is because I've had some previous experience with 3D printing at different internships I've held, so I thought it would be a good opportunity to learn more about 3D printing and to practice what I already know. I chose to create a sundial for my print to complete the task of printing something that relates to my major. First, I want to go into the background of a sundial. They were the first devices to tell time in medieval Europe. For example, when people wanted to know the time, they could look at anything that casts a shadow, for example, a tree. The sundial is pretty fun because you can bring it with you on the go. It's kind of like the first iteration of a pocket watch. For example, watches today are pretty stylish and make a point, but they're also functional and tell the time. Sundials are also very difficult to manufacture, of course the metal ones. The difficulty comes in the precision of the angles and how they have to continue to tell the time after many years. For the basics, the gnomon, which is the extrusion right here, has to be facing due north in the northern hemisphere and due south when you're in the southern hemisphere. Other than that, the longitude and latitude lines kind of vary a little bit with location and the angles of the sundial, but for my print I just went with a standard sundial. Although the I2P lab was available for use, especially for this class, I've been using a 3D printer with my senior design project. My senior design project actually does a lot of research with 3D printers, so I figured it would be useful to just use the same one. And I used a Zmorph 2.0 SX as the 3D printer. Going into the variations of design that I went through in the different prototypes, I started by making these small light blue prototypes with NGen. I had a friend who had some extra NGen from work, and I decided to do some prints with it. I had never printed with NGen before, and I heard great things about it. However, I did run out of material, and the material is a lot more expensive than PLA, so I did end up printing my actual part in PLA. To make the watch, the original prototype, which was a watch, I added some brackets, so to speak, on SolidWorks. I imported the part from Thingiverse and scaled it down and to add these brackets. Once these are printed, a friend and I were looking at them and we were saying, you know what, these are probably going to be too small to fit anything through. The numbers, the Roman numerals on the part did not come out too good. The reason is that the print, even when printed fine, which was about 0.15 millimeters, just did not look too great. So instead of trying to figure out how to print finer or print with a different material, I decided to scale the sundial larger, and with the larger scale I decided it would also be much too large for a watch, but I instead decided to stick with the jewelry idea and make it into a necklace. Well, when making the necklace and the watch, I had to switch from the watch, which had two brackets to loop something to wear on your wrist, to the necklace only needing one bracket to loop some string through and wear as the necklace. To create that, that's where the support structure came in, and originally I was printing the necklace design with support structure just to account for that bracket that would be needed to make the sundial into a necklace. I ran into some problems doing that with the support structure. The very bottom of the print did not have enough support material underneath it to be able to produce a very solid first layer for the actual part. As you can see on this design, it's a lot thinner of infill on the bottom than it is on the top. And that was a generation from the Slicer software, and I decided, instead of trying to perfect that, to print a flat sundial and then add with super glue a bracket to make the necklace. The first successful prototype I had printed with a less fine laydown pattern with about a thickness of 0.2 millimeters. The print turned out successful. There is a sundial, it is standing, the gnomon is not drooping at all. However, and the Roman numerals did not come out very pretty. They looked similar, or they looked about similar to the smaller ones, from the watch that were printed fine. So to refine this, I used a finer laydown on the finished product. This was used with 1.5 millimeter thickness laydown, and just about all of the numbers came out looking pretty nice. So the final product ended up looking like this. There were a few voids between the different layers of Roman numerals, but I think with the fine laydown pattern, it turned out pretty nice, especially the gnomon. It's nice and solid versus the less fine print laydown, which is not that solid. For the bracket, I did print this separately. I designed it in SolidWorks, and I used super glue to stick it on, and it can hold pretty strong. I'm tugging at it right now, so you can wear it around your neck. I did think it was interesting that the gnomon did not require support structure. There was an option to add support structure in Slicer for under the gnomon, but I tried it without using it as the software originally generated, and there was enough distance and the PLA got cold in enough time that there was no support needed under the gnomon, which I thought was really cool. And although I have done some 3D printing in the past, I had never printed with support material. In the past, I would just make parts that would have an angle from no less than 60 degrees so that I wouldn't need support material. However, when I decided to add the brackets to the bottom of the design, support material would be necessary. The idea of support material is to elevate any surfaces, to elevate anything under a part where the part would not reach the ground. So a 3D printer cannot print in space. It needs to have something like a table or support material to add the structure onto. Support material can be laid out in a variety of different ways. I guess the most basic support material would be a raft. Originally, the printer that I was using didn't have a very sticky bed, so I put a lot of glue, just classic glue stick glue on it, and they stuck really well. But when I was scraping them off, I didn't want to warp the part or damage the part at all. So I used a raft so the raft would take the damage if there's any damage from removing the part from the print bed. It was interesting to see the different infill patterns, the typical ones produced by different softwares. The small blue ones were produced by Cura. Cura was the software that I imported the STL files into for 3D printing, and the larger blue ones, the ones that were meant to be a necklace, were used making Slicer software. I'm more familiar with Slicer software now this semester because I've been using it for 3D design work, so that's why I kind of switched from Cura to Slicer. The infill structure on the Cura samples are more like a waffle, kind of just like a grid, and the support structure that Slicer software lays down is kind of like upside down pyramids. So it starts at the point and then goes to a square shape that eventually they will lay down a few layers of more solid type support material. That the reason they do the pyramid structures and not just a solid structure is to not waste so much material for a support structure when at the end of the day you don't need your support structure for the final print. What I've learned from taking this class was to use support material, and I think that's very useful because now I can print a lot more complex shapes, and I understand that support isn't always the best, but I know which geometries and I can manipulate in order to print them using support material in the correct places. If I was to do this project differently, I would go more into depth about learning how different softwares decide what support laydown they do, or I would create my own support structure geometrically in a 3D design software. I hope you have enjoyed my video, and I hope you enjoy my 3D printed sundial necklace, and thank you for your time.